Hello everybody, we will complete the unit of thermal physics. Our lesson today called latent heat. By the end, you will know what is meant by the process of melting, boiling, solidification and condensation. Also, we will calculate the value of latent heat. Melting and boiling. Firstly, melting point, also called liquefaction point. How can you define melting point? Melting point defined as the temperature at which the solid and liquid forms of a pure substance can exist in equilibrium. As heat is applied to a solid, its temperature will increase until the melting point is reached. More heat then will convert the solid into a liquid with no temperature change. So, before reaching to melting point, the temperature of the substance will increase. During melting or when melting point is reached, temperature does not change. When all the solid has melted, additional heat will raise the temperature of the liquid. Melting temperature of crystalline solids is a characteristic figure and is used to identify pure compounds and elements. Boiling point. Boiling point defined as temperature at which the pressure exerted by the surroundings upon a liquid is equaled by the pressure exerted by the vapor of the liquid. Under this condition, addition of heat results in the transformation of the liquid into its vapor without raising the temperature. So, during boiling point, temperature of the substance does not change. Liquid varies according to the applied pressure. We know before that boiling process depending on the surrounding pressure. Now we will know some differences between boiling process and evaporation process. Boiling process occurs at a fixed temperature, but evaporation occurs at any temperature. Boiling relatively fast process, but evaporation slow process. Boiling takes place throughout the liquid, but evaporation, as we know before, takes place at the surface only. The molecules on the surface that evaporates firstly. Boiling or during boiling, bubbles are formed, but no bubbles formed during evaporation. Temperature remains constant in case of boiling, but during evaporation, temperature may change. During boiling, external thermal energy source required, but evaporation, heat from the surroundings is enough, does not require any energy source. These are the differences between boiling and evaporation. Condensation process. Condensation is when a gas changes to a liquid. As a gas loses heat energy, they also lose kinetic energy, causing them to move slower. Their intermolecular forces of attraction become more significant, pulling the molecules together and allowing them to form weak bonds until they form a liquid. A pretty common example of condensation is when your mirror steams up after a shower. So condensation, defined as the process of changing matter from a gas state to a liquid state. According to kinetic theory, on cooling, the particles of gas lose their kinetic energy and their speed decreases. The decrease in their speed reduces interparticle space and the particles come so close so that the attractive forces between them increase and the gas gets converted into a liquid. Solidification or freezing. Solidification is when a liquid changes to a solid. As liquids lose energy, their molecules slow down and form more intermolecular bonds with one another. They become locked in place and thus they form a solid. So, solidification defined as the process of a change of matter from a liquid state to a solid state. The constant temperature at which a liquid changes into solid by giving out heat energy is called freezing point of the liquid. According to kinetic theory, when liquids are cold, the thermal energy of particles decreases. Thus, cohesive forces between the particles strengthen to such extent that the particles cannot have relative motion with each other and they occupy the fixed position. Thus liquid gets converted into solid. So during freezing point also the temperature of the substance does not change. Same melting and boiling point. Latent heat. We know before that during melting, freezing, boiling, the temperature of the substance does not change, and substance can exist as a liquid, solids during melting, or liquid and gas during boiling. The thermal energy at this temperature called latent heat. Latent heat can be understood as energy in hidden form which is supplied to change the state of a substance without changing its temperature. So, during melting, the substance changes from solid state to liquid state without changing in temperature. Also, during boiling, the substance changes from liquid state into gas state without changing in temperature. The latent heat associated with melting a solid or freezing a liquid is called the heat of fusion. But the heat associated with vaporizing a liquid or a solid or condensing a vapor is called the heat of vaporization. The latent heat is normally expressed as the amount of heat in units of joules or calories per mole or unit mass of the substance undergoing a change of state. So we have two types of latent heat. First type is latent heat of fusion. Latent heat of fusion defined as the energy supplied when a substance changes from solid to liquid. It is called the latent heat of fusion because a lot of solids are fused together by melting them and combining them. Same in case of creation of alloys. Second type called latent heat of vaporization, and it defined as the energy supplied when a substance changes its physical state from liquid to gas. It is called latent heat of vaporization because it is the energy supplied when the liquid vaporizes. We call it latent heat because we can't measure this using a thermometer. The temperature does not change, as we know, when melting or boiling, because this latent heat is used to break the bonds between the molecules. So concentrate. If I ask you why the temperature does not change when melting or boiling, this is because the latent heat is used to break the bonds between the molecules. The latent heat of vaporization is usually greater than the latent heat of fusion because normally more bonds have to be broken when boiling than when melting. The common example of latent heat is water. When a pot of water is kept boiling, the temperature remains at 100 degrees Celsius until the last drop evaporates. So, during boiling, the substance remains at 100 degrees Celsius until the last drop evaporates. Why? Because all the heat being added to the liquid is absorbed as latent heat of vaporization and carried away by the escaping vapor molecules. Similarly, during melting. During melting, the substance remains at 0 degrees Celsius and the liquid water that is formed with the latent heat of fusion is also at 0 degrees Celsius. This curve is very important. This curve illustrates the latent heat of fusion and latent heat of vaporization. Also, it shows the states of matter. This curve consists of 5 lines. First line AB, second line BC, third line CD, fourth line DE, and fifth line is EF. We will start with first line, which is AB. Line AB refers to solid state. So in exam, if I give you this curve and ask about the state of matter at line B, so at line B refer to solid state. Line BC, a substance found in two states, liquid and solid. Temperature remains constant. As we see at line B, temperature does not change. So temperature remains constant at line BC as solid turns to liquid. The absorbed energy used to break bonds between molecules. So line BC refer to two states, solid and liquid. Also, line BC, the temperature of line BC does not change, remain constant, because the absorbed energy used to break bonds between molecules. Line CD. Line CD refers to liquid state. Line CD refers to liquid state. And as we see, the temperature increase during line CD. Line DE. Line DE, a substance found in two states, liquid and gas. Temperature remains constant, as we see. Temperature does not change. Line DE, temperature remains constant as liquid turns to gas. The absorbed energy used to break bonds between molecules. So, line DE refers to two states, liquid and gas. Temperature remains constant as liquid turns to gas. The absorbed energy used to break bonds between molecules. This for line DE. Last line EF refers to gas state. This curve is very important. This curve illustrates phase changes with heat entering 1 gallon of water. First line of curve, which starts from -25 to 0, shows a solid state of water. So first line refers to ice, as we see. This line or temperature increase during this line from 25 to 0 degrees Celsius. Second line, which refers to ice and liquid or solid and liquid states, the temperature is constant, does not change. We know that this temperature called latent heat of fusion. The temperature does not change because the absorbed energy used to break down the bonds between solid molecules or ice molecules. Third line, which refers to liquid state, start from 0 till 100 degrees Celsius. Fourth line, which refers to latent heat of vaporization still constant at 100 degrees Celsius. Also, we know temperature does not change because the absorbed energy used to break down the bonds between molecules of liquid to change it into gas. So, this temperature refers to latent heat of vaporization. Last line, which refers to gaseous state, start from 100 degrees Celsius. Calculation of latent heat. Specific latent heat defined as the amount of energy in the form of heat required to completely affect a phase change of a unit of mass, usually 1 kilogram of a substance. So it can be calculated by energy equal mass times specific latent heat or by using simple Q equal M times L. So L, which is specific latent heat, equal Q divided by M. The unit of latent heat from the formula joule per kilogram. This for calculation of specific latent heat. Now we are going to solve some questions related to this lesson. The graph shows how the temperature of a pure substance changes as it is heated. So we have a pure substance heated, start from 30 degrees Celsius. First question, at what temperature does the substance melt? We want to measure the melting point of the substance. At what temperature does the substance melt? Second question, label the section of the graph with letter X where the substance exists as liquid and with letter Y where the substance exists as both liquid and solid at the same time. First question, at what temperature does the substance melt? We know that melting point occurs at constant temperature. So which line refers to constant temperature? Yes, second line. This line at about 55 degrees Celsius. So melting point or the temperature at which the substance will melt at 55 degrees Celsius. After that, the line that refers to liquid state is this line. Third line, first line solid, second line solid and liquid, third line liquid only. And the line that refers to both liquid and solid, second line. During melting, the substance exists at both solids and liquid state. Second question, what is the physical state of water at 250 degrees Celsius and at 100 degrees Celsius? We know before that water boils at 100 degrees Celsius. So in temperature more than 100 degrees Celsius refers to gaseous state. So at 250 degrees Celsius water exists as gaseous state. But at 100 degrees Celsius water can exist in both liquid and gaseous state because this temperature refers to boiling point of water. Third question, for any substance, why does the temperature remain constant during a change of state? Why does the temperature remain constant during melting, during boiling, during freezing? Why does the temperature remain constant? Why? Yes, because all the heat supplied to increase the temperature is utilized in changing the state by overcoming the force of attraction between the particles. So, during melting, during freezing, during boiling, the temperature does not change because this temperature or this energy used to break down the bonds between molecules. This is the end of our lesson. Try to solve your homework that uploaded on Moodle. Thank you, my students.